All right, good afternoon, everyone. Thank you for taking the time out of your busy schedules to join us on this u-blox services webinar. The theme of today's webinar will be to discuss the ultra-low power global cellular connectivity solution from u-blox, otherwise also known as Thingstream, which is suitable for IoT and battery operated applications, as it provides similar power consumption levels to your standard LPWA networks on a traditional cellular network. Just a quick introduction on the team. I'm Ronaldo Fibiger from Altron Arrow, who is the local distributor for the u-blox services or Thingstream SIMs, both plastic and chip SIMs in South Africa. I would also like to introduce the team from u-blox services, Neil Hamilton, who is the head of service sales, and Nick Hayes, who is the head of customer operations, who will be doing the presentations for us. After the presentation, we will also have a short Q&A session just to address any questions you may have. And also note that if you register a Thingstream domain and order a SIM from us, we will give you a month's free access to the platform, as well as engineering systems on the SDK integration. Great, so I'll hand over to the team at u-blox.
Brilliant, thanks Ronaldo, and good afternoon everyone. Thanks very much for your time, as we said. So yeah, I think the whole subject that Nick and I are going to run you through is all focused, as you can tell, on kind of preserving battery power. And focusing on those IoT applications when devices typically are dispatched to the field and you don't really want to see them again. You don't want to be replenishing batteries or worrying about the costs of the life cycle of the applications that we build for customers. And two of the key things I think are common to most of the use cases we certainly come across when it comes to IoT effectively. One of them is around message frequency. So again, different applications obviously have different purposes and different reasons for communicating with the cloud or getting their conditions or their sensor information into the cloud. So we can see applications like condition alarms, which might wake up once a week, once a month, or on a trigger because something's happened. So again, these have to be fairly autonomous. And again, there are multiple reasons why you will configure a particular application a particular way, but again, using a battery to power those. And again, they might go off to live for 10 years in the field. But at the other end of the scale, and again, still, if you like, on the battery IoT spectrum, are things like pet trackers or monitoring systems that are more frequent, maybe down to the minute, in some cases, or even, we're working with, in some cases, with stolen vehicles, stolen, bikes, things like that, where temporarily you might even need a much higher frequency, but after the bike has been found or the vehicle's been recovered, you fall back to a lesser cadence. So it's that flexibility that we see many applications require. And so today we're going to cover some of the technology that we believe can really help with this stuff and improve and simplify the way you can develop a solution. In addition, it is that lifespan. When we look at cargo tracking, we have a use case today. We'll be looking at, the typical use case where, again, you need a particular type of chemistry battery, which will be dispatched and you won't want to see it again, or the customers don't want to touch it for 10, 15 years maybe. So how do you solve the problem of enabling that use case when you're battling with many different variables, from antennas to the modems to the networks, everything else that's going on? It's a challenge, and we believe that there are ways to overcome these and simplify the way we think about building IoT applications. And then obviously there are more frequent use cases where maybe the purpose of the use case enables someone to want to recharge. So pet tracking, okay, consumables and wearables. Again, we're more used to charging them or putting them on wireless charger pads or whatever we do these days. So we see there's again a broad set of use cases that need to be catered for, and the u-blox services offering is really compelling because it does map to many of these use cases, as you'll see. And one of the most common areas in today's kind of webinar is very focused on this. We often talk to engineers involved in projects, and from the outset, they're really focusing on the cellular module. They understand they're not, they might not use Sigfox or LoRaWAN for whatever reason, but they're going to therefore use cellular. We start looking at the attributes of cellular, and we start looking at low power wide area options with NB-IoT or CAT-M. And then we get into the firmware, and you start looking at all the options within PSM or EDRX and all these different kind of power saving configurations that the modems offer. But we can spend a huge amount of time in there worrying about that stuff, and often it possibly aren't even optimized just for your home network. when these settings aren't the same on roaming networks. So even if we're building a product, for example, in South Africa, and we're going to dispatch it to South America or North America, it's highly likely none of those settings or configurations will bear any relevance on the actual end solution. If anything, it might even cause more problems because you start picking, finding new challenges. So we generally see in most conversations we're having with our customer base is when we maybe not worry about that stuff so much, because regardless of how you're configuring your modem, and you might even be, and as you'll see later, you could just use a regular 2G or even Cat1, and you can still get the power saving benefits of what's promised from IoT if you focus on the other part of the solution. If we start looking at the language these devices speak, if we look at the protocols they use and how security is implemented, that has a huge impact on battery time and the costs of operating these services. And that starts leading us into looking at the different, as I say, these languages or protocols that are being used, of which there are a number of options in the market. If you invariably, we find customers who start discussing the benefits of lightweight M2M from an application protocol point of view. Typically, that's obviously built on CoAP, but we find these conversations are when customers are they're working closely with the telco, and the telco are promoting these protocols, which are useful in many use cases, but they're not always relevant to an actual, the actual customer use case. When we're looking at maybe the one-to-many kind of broadcast style protocols where we don't need to have an individual device, communicating directly or having a conversation with the cloud. If it's a fleet of sensors that just need to be reporting, their status, lightweight M2M and CoAP is probably not the right protocol at all. We start looking at MQTT because it's built for that purpose. And going further, we're going to explain today a little more about MQTT-SN, which is part of the MQTT specification, but it's really focused on constrained networks, and it's invaluable for reducing battery consumption and improving the efficiencies of communication. So Nick will cover a bit more of this. The key things we want you to think about here is really when thinking about the protocols you use, it's around that use case. Again, as Ronaldo said, we're focusing on battery powered applications here. Now, MQTT-SN is relevant for non-battery powered applications. It's perfect for lightweight powered sensor applications, but some of its real attributes come in when we start looking at how much it actually consumes energy, and we'll look at that in a moment. But battery longevity can be increased when we're hardly on air, when the device is rarely having to wake up and talk to the internet, and when it does, it's doing it very briefly. So that's some of the benefits of the protocols that we're going to explain today. And obviously the payload side as well. We, as Ronaldo said, we have our own SIM. It's a global roaming SIM that enables this communication. So this MQTT-SN communication anywhere in the world. And because it's operating within, if you like, effectively a private network with our roaming SIM, then security is good enough. Security is built in to the whole communication flow. So we don't need to add DTLS or any kind of certificate management on top, which is usually what bloats the payloads in our regular IoT applications. So again, it's something to focus on here. It's all about optimizing the way in which devices communicate with the cloud. So with that, Nick, maybe you can tell us more about SN specifically and some of the attributes.
Yeah, thank you, Neil. Good afternoon, everybody. So MQTT, as Neil mentioned, is a publish and subscribe protocol. It's very lightweight, designed for these kind of IoT applications. But it's still going over TCP/IP. There's still some requirements for adding layers of security to have MQTT-S, potentially handling certificate exchange and all that kind of thing as well. All of which contributes to the amount of time that your device needs to be on air and therefore consuming battery. So what MQTT-SN does is add some additional further optimized features, particularly designed for power and bandwidth constrained environments. The SN in MQTT-SN stands for sensor network, and that was what was at the forefront of the minds of the designers of this variant of the specification. So a couple of things that it brings. Firstly is topic aliasing. So when you're publishing messages on MQTT, you can have quite deep and complex topic structures. going down many layers. See, when you're publishing to these topics, you need to send that topic name over the air. MQTT-SN allows you to assign an alias to that topic. So you declare the topic on the broker, assign it an alias, and then when you publish that topic, you're just referring to that simple integer alias. So you're using fewer bytes over the air and therefore less time. There's also a sleep mode. So the device can tell the broker that it's going away for a period of time. And then during that time, the broker will queue any messages that are published to topics that that device is subscribed to. And so they're there waiting when the device then wakes up. So it can then send a simple ping message to the server to say, hey, I'm back. And the broker will then flush the queue and deliver any waiting messages down to that client. And then there's an additional quality of service level which is introduced. So with regular MQTT, you have quality of service 0, 1, and 2. And these give you varying levels of handshake back from the broker to determine the deliverability of that message and get confirmations back. MQTT-SN gives you a quality of service -1, which allows you to actually publish a message without connecting in the first place. So if you're using the combination of topic aliasing with quality of service -1, you can dramatically reduce the number of messages and handshakes with the server that are going to get your message into the cloud. If we can move on one, Neil. So just having a look at what that means in terms of your power and the number of bytes that are going on over the air, and therefore the time that your radio is on. If we look at MQTT Anywhere, examples here using 2G networks and LTE networks, and this is a full LTE Cat1 modem, which and again 2G and LTE Cat1 people will typically think of as being very power hungry modules, but when you're using MQTT Anywhere with our unique security with the private tunnel that the data is traveling over, you can see that actually the relative current that's used on the transmission is very low. If you compare that across to the number of bytes over the air, then you see that sending a simple 12-byte payload using MQTT-SN, even when that's going over Cat1 with UDP, that's just inflated up to 34 bytes just with some of the protocol overlays. So 2.8 inflation factor. If you want to do that same message using HTTPS, because obviously everything needs to be secured, then you've got a 473 time inflation factor just to send that same message over HTTPS. So a massive impact on your time on air and your power budget just by using a traditional HTTP protocol for sending that message. If we can move on now. So yeah, so as we say, it's about getting some perspective when you're thinking about the hardware design. Lots of people will tell you that LPWAN is really what you need. It's not necessarily true. Think about where your device needs to operate. Cat M1 and NB-IoT networks are still very much in their infancy. Coverage is improving all the time, but there's nothing like global coverage with Cat M, and in many cases nothing like even national coverage when we're talking about NB-IoT. And certainly with NB-IoT, there's very little chance of any roaming. So you have a number of hurdles to get over when you're looking at those low power solutions. And actually, when you look at the kind of power savings you can get with the right protocol and the right connection, you can get similar performance from modules like a full-blown Cat1 modem, which you may have previously completely ruled out just because of there's no way that it could fit the power budget. It's not always true, so it's worth just investigating those a bit deeper. So let's take a look at what some of that means in practice. I've got just a little demo which I can show you, which will just illustrate how MQTT-SN and those power saving options can help you save your time on air, and also how some of the other features in the Thingstream platform, with the flow editor in particular, can help you optimize that power saving on the device. So hopefully now you can see my screen.
Yeah,
great stuff. So I've got set up here a u-blox SARA R422 modem. And this modem actually has an MQTT-SN client built into it. So you can, with the R422 and the R5, you can use the native SN clients on the modules and get yourself up and running and communicating with the Thingstream broker in next to no time. There's no need to implement the SDK necessarily. You can just work with the native client. So that's what I'm doing here on this demo. We take a look at my MQTT client. Just have a quick look at the settings that are in there. So this is pre-configured with my device identities, my client ID. These are the details of the server endpoint that I'm connecting to. So now I can go through and I can connect. It's just all run by simple AT commands because I'm using the native client. So do my connect equals 1. That goes off. I get the OK back from the broker to say that it's connected. A couple of seconds time, my traffic log will update, and we can now see that I've done that connect. Now that connect has cost 2 messages over the air. There's a connect and there's an acknowledgement that's come back from the broker. If I now want to publish a message, the first thing I would have to do is register a topic. So I'm going to register this topic, which is sensor temp reading. If I register that topic, I get an OK back from the broker, and that gives me a topic ID to use in my publish. And I see now I've got a further 2 messages, a register and a regac back to say that topic is now registered. And then I can go in and say, right now I want to publish my message. I'm just going to publish a simple text string here, 23 degrees, with an MQTT quality of service of 1. So if I publish that message, I get the OK response back. A couple of seconds time, this will refresh. This isn't showing how long it takes to actually send the message. This is just the traffic log here is polling for updates. So the actual publish happened much quicker than that. But now I've got my publish and my publish acknowledgement back. So I've gone through now 6 messages in order to make that publish through to the broker. And I can see if I look in my flow, just in my debug output here, here's my message that's come in, and here's my message payload, 23 degrees. So if I want to optimize that using some of those power saving features in SN, I can do it very simply. If I just come in and I'll just disconnect now from the broker to get my client back into a disconnected state. I should get the OK message back that that's happened. I see my disconnect and my disconnect confirmation have gone back. So the client's now not connected to the broker at all. We'll just clear those logs down just so that we can see now the comparison when I'm using a predefined topic. I come to the broker, let me just grab that topic name. This one, oh, sorry, this one. The first thing I'm going to do is register this topic on the broker. So just in Thingstream, create the topic, put the topic name in, create it. Now I want to assign it an alias. I'm going to give it alias 110. So that topic is now registered on the broker with an alias of 110. From my client now, I can publish a message to that alias. So here's my command, publishing with this is quality service -1 represented by the 3 here, the topic alias 110 and that 23 degree message. I just jump into my flow, just clear that debug output, run back to here, hit send. That message is now published, and here it is in my my output, 23 degrees. And if we look at the traffic log for that message, now there's just one message doing that MQTT publish. So I didn't have to connect, I didn't have to register the topic, I just did the publish. So my time on air is massively reduced already. Now we think about, okay, how's this message going to get out to wherever it needs to go? I've got my back-end system that requires a JSON payload. Well, you don't need to send JSON from the device. You can have your device sending its payload in the most efficient way possible. It may be just a bit of binary data that it wants to send. And now you can do the heavy lifting here in the flow editor in the cloud, where you're not constrained at all. So let's have a look at how that works. We've got the message coming in here. Here's my 23 degrees. I want to put that into a payload, and I want some extra information as well. I want to know what's the name of the device that's publishing this message and what is the serial number for that device. Now these are all things which are known by the broker. If we look at the details for my thing, this is the representation of my SIM. Here's my serial number. I've given it a friendly name. The device itself doesn't need to know that or send that over the air. We can add all that stuff into the payload through the flow. So if you look at my function node here, I've got my original payload coming in, message payload. I'm storing that into a variable. I'm now resetting that payload and adding my additional data to it. And this is done using some of the additional objects in the message object. So if we look at message origin device, there's a bunch of metadata in here about the device that sent that message in, and I can reference those values here in my function node. So I'm adding in the given name and the serial number, and then I'm putting the reading that I got from the device in as a variable called temp. So if I now connect this part of the flow up, hit save, just clear my debug output, go back to my client and send that message in again. Then we'll see in the debug output here, here's my original message coming in with the 23 degrees. And now here's my updated Java, my updated JSON object with the device name, the serial number, and the temperature added in. So now I want to publish that to my enterprise system, which has a REST API. And that has a bunch of things that needs to add some additional information. So maybe I need some HTTP headers and some kind of authorization token. So here on my thing, I've set up a property called password, which is storing a value which could be used as a token for identifying that client on the enterprise. So I'm setting up my headers in here, adding that password value in, and then posting that out to my endpoint. So if we open that up, we come to here, clear that data out again, hit save, publish my message once more. Then I can see that the message arrives in the platform as normal, gets that converted to a JSON object. Here the headers are added in. So if I look now at the object, I've got a headers value here with the headers that I added in, and you'll see now that that's retrieved the password that was obfuscated in the UI, but now my password is back to be sent over the air. That's then going into my HTTP request, and I see down here I get a 200 response back from the HTTP. And if I come in now and look here and hit refresh, then here's my message. And it's my JSON object has been posted out to the enterprise. Here's my authentication token, and here are the other headers that I set up. So all of this additional data that doesn't need to be sent over the air at all can be added in on the fly by your flow. Again, just further reducing the weight of the message that the device has to send and the time that that device is on air. And I'll hand back to you, Neil. Amazing,
Nick, thanks. Nick, could you just also touch on the other output options, just just give a quick flavour on what's available.
Yeah, for sure. So there's a number of different ways of getting data out. Lots of different nodes in the palette here. This one's doing an HTTP. It could equally be doing an MQTT Publish. You can send SMS. You can send an email to someone. You can FTP a file somewhere. And then we also have some strong type nodes for AWS. So a bunch of, you can store that data into DynamoDB or in an S3 bucket, or call Lambda functions in AWS to do other things with that data once it arrives. And then connectors for popular IoT platforms like Microsoft Azure and IBM Watson. And they're as simple as dropping the node in and configuring it with your Azure connection string, telling it which protocol you're using to speak to Azure, and then that's it. You just connect that up to the end of your flow, and that message would then be published into Azure, or whichever other of these connectors that you want to pick.
Brilliant. Thanks, Nick. I think that highlights, you'll find that in u-blox we have a family of services called IoT Communications as a service, because it's more than just the connectivity. We see that very much is only, typically connectivity is referred to as, usually in cellular context, as just a SIM and some data from an operator. But there's so much more that has to be done to build the end solution, and we've tried to take care of all of, or as much of it as possible, within the kind of standard offering that we have, which obviously includes, the SIM obviously as well, to give you the access. Okay, let's move back to the PowerPoint. Hopefully you've got that back, Nick. Am I showing the screen again?
Yep.
Yep, that's all good.
Okie doke. So if we take a look at just a couple of customer use cases, just to give some context, how what you've seen here and some of the things that we've explained helps customers solve problems effectively. Two common use cases: one, cargo tracking. I'm sure many of you are familiar with maybe building or developing tracking devices. The challenge is probably common globally, where, as I said earlier, these trackers need to really live for more than 5 years in the field, if not longer. Many of them just need to ping a day where the location is. Some might be connected up with refrigeration units, so they might have to give some conditioned monitoring as well, maybe a little more frequently around the conditions of the refrigeration capabilities or status of the device. But ultimately, this is something that needs to go and live in the field. And then on top of that, the field is big. It's a global product. These cargo trackers, or the containers, travel around the world, as we know, or certainly across continents in many countries. Because of their use case, the cheaper the BOM can be, then the more that can be sold. So again, there's always this balance of, how do we make a cheapest possible device with the maximum business capability? And so again, by removing some of the overhead from, having to have larger MCUs or memory, all the other stuff, because here we're using a very lightweight protocol, some of that is now possible. And then the operating costs of this, again, if you think about a roaming context, if we have a container that travels across South Africa, maybe leaves for Europe, then comes back, that's, we're using data, there's roaming data involved if it's a regular kind of HTTP-based solution. If those products roam into Ghana or anywhere else in the continent, the data rates go up, and you're fighting these unpredictable costs of how much it actually costs for tracking because of the various different roaming fees that people incur. And that's when you come across steering. Many operators talk about steering platforms where they can, we'll steer your data onto your SIMs or your device onto the cheapest network in country. Well, that may not be ideal, because again, the cheapest network, the base station, could be 10 kilometers away, and you're burning battery trying to connect to the thing. But if you could just hop onto the nearest cell tower, send your payload and turn off again, it makes a lot more sense. So this is where we see the roaming capabilities coming in from what we're offering, and the ability to communicate in many cases. You may want to report back a status to something when it's in or out of a geolocation. So again, as Nick just showed us, there's upstream systems that you need to be connected to as well. So that's the challenge. How do you make that simple? So when these customers, and they do, and many of you probably experience, we have various low power wide area networking options available to us. But again, in a classic cargo, tracking experience, Sigfox isn't going to cut it, because it might be okay in a particular part of the country, but it's not going to be consistent. So, once you travel across a border, you've lost your device until it arrives back again. So that's not particularly helpful. LoRaWAN, very similar. There are certainly some of the European countries, you've got good coverage. Often when it's the likes of KPN or Orange, you've built a LoRaWAN network on top of their cellular network. But again, as soon as you cross a border, there's no consistency. So that doesn't help. So it is very much cellular where you're looking. And even with NB-IoT and LTE, as we said earlier, it's Nick pointed out, it's patchy at best. You might find NB-IoT is very good near where the carrier's headquarters are, and that's where the labs are. But as soon as you start moving into rural areas, there may never be any offerings or any capabilities. And certainly LTE-M is probably the most prevalent now. It's picking up pace in terms of its availability. Often you'll see with roaming agreements and roaming capabilities that LTE-M is being included now in the LTE roaming side of the agreements that the carriers have. So there's challenges, and it's coming. So rather than maybe looking at a specific modem that's purely a Cat-M modem, it's sensible for customers to look at something with 2G as well. And so this is where we start to, the use case starts to make sense for the cargo scenario, where if you have 2G, well, still most of the world is providing you 2G. There are turn-offs in most of those countries where you see it turning off. There's usually a Cat-M network popping up. So that's kind of how we foresee the future. The next few years is going to be this patchwork. So having multiple bearers on board the modem is essential. Ultimately as well, we are also looking at things like Cat1bis, which is going to be a very useful style of modem for these types of applications. But today we see by far the most popular being, the LTE-M plus the 2G. And even though we refer to 2G as a fallback, you often see it's falling back to the Cat-M, because there's more networks available on 2G. So this is the approach that this company's taken, with thinking about the cost of the modem and in kind of making a relatively small tracker. And so that's their approach. And so with the global roaming SIM, that slick and slim protocol and the platform, bundled with the commercials, which is again the offering that we have in the u-blox services portfolio, is purely pay as you go. So we've approached this with trying to make the technical implementation simple, as Nick just showed us, but in addition, have customers only pay for the use of the platform or the communication services as and when they're consumed. So again, the commercial models here are paid by the number of messages consumed. There's no other kind of charges for rental and line rental and roaming, and there's no concept of this. It's purely pay for the MQTT messages consumed, and that fits brilliantly with lots of use cases when a container might stop in a port for a while. So whilst it's there, maybe you put it into sleep mode, for example. So very flexible, and I think that's key for IoT, given many use cases aren't still settled. Customers are still working out what works. So during these early stages, proof of concepts and early prototyping, this technology really is helping evolve the use cases. We've touched on this, and another interesting use case, and this is very much around things that don't move. So coming back to battery operated use case, here we have one with Lumkani, providing fire protection services effectively across South Africa and beyond. And again, here we need these devices that you see on screen talking to a central base station that's battery powered, because we cannot rely, the use case dictates that we cannot rely on any power to these systems that are effectively a mesh network of smoke alarms and smoke detectors, enabling the quick access to notifying people when there is fires or problems. So an essential service, but the challenges are no power, and these are going to work in various places around the world, including Bangladesh and elsewhere in Asia. So again, having a universal unit, a single SKU that will confidently work anywhere, consume very little power, and fit the use case is essential. Cellular doesn't, regular data doesn't cut it, because again we have to visit and change power in the batteries and things. So again, this is another common use case where we start to look at the usual scenario, which of these work. Well, as you can probably imagine, the global nature of this again leads us into the scenario of cellular, but then none of these options, despite the hype in the market, the LTM or MBIT, it's not relevant for certainly Sri Lanka and Bangladesh. It's still 2G. So again, it's still very relevant. And again, because we're providing the MQTT-SN solution here, then you've got the global footprint with 2G, you've got the low power usage, the security is built in, and the overall solution, comes together again in this pay-as-you-go type approach, which is again great because you might have 500 of these things sitting in a country waiting to be deployed, and as they're deployed, then you can start paying for the use of them. But if they're not deployed, why pay? So that's kind of the approach and the solution that we looked at here. Then beyond just the pure communications, there's another area that often is not overlooked, but again, it's kind of a challenging area to work out power usage. How do you reduce power in terms of location? And so when we quite often look at many of these use cases, in many use cases, the asset tracker, the cargo tracking device, it doesn't need to know where it is. So in theory, you shouldn't really need the GNSS receiver to be staring at the sky for 30 seconds or a minute, trying to work out where it is before sending that to the cloud to tell the cloud where it is. And we see this is, another, it's another area where there's a lot of focus on trying to reduce that power consumption because it can be significant, especially when, line of sight to the sky is tricky in various different conditions. So we have within the u-blox services portfolio, something that's using something called measure and process. It's effectively a snapshot technology where the premise behind this is, let's just grab a few seconds of information from the GPS or the different constellations we have line of sight of, and just send that information to the cloud and then turn the device off. So again, using MQTT-SN, as Nick just explained, to send this payload, but we've now got the GNSS receiver on for a very short space of time. As I say, 3 to 5 seconds is all you need to gather a snapshot, where in the cloud, the magic happens. You can work out where something is to within, say, 5 meters. And then this is, making huge differences to power consumption, as well as the communications piece that we've just mentioned prior. To the point where in certain scenarios, and again, we've got different information we can share with you if you're interested, but you could be saving up to 90% of the power consumption you're typically using for the regular way of obtaining a position using GNSS. Within the service in the data flow manager Nick just shared with us as well, you might have scenarios where you don't always have line of sight of the sky, and you might be able to, via another sensor on the device, perhaps grab Wi-Fi MAC addresses. So that takes it one step further, where in the absence of GNSS or even cell IDs, which is another parameter we can use, we can be helping the efficient location of something if it doesn't need to know where it is itself. So we think this is a really interesting sort of breakthrough in improving, again, the efficiencies of how asset trackers work. And there's multiple kind of business benefits here. One is just battery power purely. So maybe cheaper batteries could be used for a use case, or possibly just devices can live much longer in the field. And again, all of that is supplied and available through the platform that Nick just shared with us. So in our conclusion here, before we move on to Q&A, I think it's what we're trying to highlight. The hardware is important, but there's a lot more to consider when it comes to saving power and creating overall operational efficiency for IoT. The protocol is essential, and we're advocating there's more and more adoption of MQTT and of SN now, which is really great because we are seeing more and more excellent kind of use cases globally of where people are benefiting from that. And again, we touched on this in the demo, but getting that data from the device to the cloud, often we might be focusing just on building the device, and we might be putting a SIM tray on board the device, and someone else can take care of that problem of converting the data into something meaningful in the cloud. Well, again, all of that's taken care of within this particular service, MQTT Anywhere, which is paired with the SIM. All of that's included, if you like. Everything's taken care of within the solution. So simplifying and making it more cost efficient and ultimately preserving more battery power is kind of the focus here. And it's all centralized, if you like, around this efficient protocol usage. So as Ronaldo said, we're happy to talk to customers about specific use cases, as are the Arrow team. But yeah, interested to see if we have any questions at this point on anything that you've heard from myself and from Nick. Mandy, I've not seen the questions tab, so you might have that with you.
We've had two
Neil,
questions.
there were,
Nick,
there were a couple of questions which I've answered in the chat, but we can just pick up now. Both from Marius. So he asked, are the quality of service 1 and 2 type messages guaranteed to be received on the server if there's a proper connection? So the answer to that is yes. The server will, as we saw in the demo with the quality of service 1 message, there's a publish and then a pub-ack. So when the client receives the pub-ack, that's how it knows that the broker received that message. Quality of service 2, there are a couple of additional rounds of handshake, as quality of service 2 is guaranteeing that it was delivered once and once only. So yeah, there's an additional layer of handshake there, but in both cases there's an ACK back to the client to confirm delivery. And then the second question was about billing, and are there plans to add device ID next to the used messages that are billed for? So in the UI, you can see how many messages have been consumed. Actually, if I just share my screen, I can show you. Give me 2 seconds. So if we look on the things list on the activity tab here, I can see how many messages this particular device has consumed, which plan that device is on, and how long there's left before the plan renews. So there's a view of the current month, which is available in here. We're also going to add in, I think it's actually probably in the sprint we're working on now, there will be an indicator on here to show when that plan started as well. So you can see when it's going to renew, but you can't necessarily see when it began. So we're just going to add the plan start date on here as well, just to make that a bit easier. And then there is also a roadmap item to make historical usage at device level viewable in the UI. So it will be possible to go back and look for the last few months about how many messages an individual device has used and what plan they were on when they did it. But it's not practical to show that at an invoice level. If you imagine, a domain with 100,000 devices on it, that would make the invoice pretty unreadable. But we will add that to the UI here. If there's any other questions, Mandy?
Marius has just written in, I have found in my test that no ACK was received, but my messages were published by the flow, ?
So that can happen if you're publishing quality of service -1 or 0, but not if you're publishing at 1. The message wouldn't go through the flow unless, I suppose there's a possibility that the server could send the ACK, but the client doesn't receive it for some reason, if there was some problem with the connection there. So in that case, the server would assume that because it's sent the ACK, it will assume that the client receives it because there's no ongoing handshake from the client. So that might explain if you've seen that scenario with a quality of service 1 message. But the broker itself won't release that message and treat it as published until that whole handshake has been completed from the server's perspective, at least.
Brilliant, thanks, Nick. And we've got another question here. GNSS post-processing, is this also done in the Flow app?
So if we're talking about Cloud Locate, then yes, there is. So there are specific Cloud Locate type things which just publish their message to a topic, and all the post processing is done behind the scenes. there is a cloud locate node in the flow as well. So if we go back to my flow editor, if we look in the Thingstream section, there's a cloud locate node here. So if you have a device which is taking the GNSS measurement readings and is using MQTT Anywhere, then that could publish that as part of either just as a payload on its own, or as part of a payload with other sensor information, and then have the cloud locate node in here do that processing and calculate the location from there.
Brilliant. And just one last question. Will we be seeing the ability to configure TLS parameters, certs, etc. on HTTPS calls from the portal at any stage?
So at the moment, we're not planning to add that into the node here. I would imagine in most cases it could be done using header values. But if there's something specific that you want to do for TLS, then if you drop an email into support@thingstream.io, then we can take a look at that. That will, requests like that can go through into the product team and be looked at to see if that's something that can be added into the node. If there's not already some other way of doing it, and if there's another way of doing it, then they can confirm and let you know.
Brilliant. And just one more that's just popped in. How big are those cloud locate messages?
So that depends entirely on how long you leave the measurement readings going for. But they can be as small as, I think, something like 15 bytes is probably just for a single reading that will let you get a location back. But yeah, they're generally very small. You only need to have the receiver on for a couple of seconds to get a reading that a location could be calculated for.
Brilliant. Okay, I think that's all for questions.
Amazing. But obviously send more questions into the Arrow team, and if they can't answer them, we're here as a backstop to work with you as well. So Ronaldo, anything else you'd like to cover?
No, thank you, Neil. All good from my side. Thank you for the presentation. It was very informative.
Fantastic. Well, we'll have copies of this available. They'll be distributed. And like I say, any questions, send them in. Hope you found that really interesting. And look forward to hearing from and working with some of you guys. Really appreciate your time. Thanks very much.
Yeah, thanks everybody.
Thanks everyone.